Building AI agents for real life, for production. In this short video, I'm going to share with you lessons learned and a few ideas based on my recent exploration and observations using the ultimate AI agent, which is an agent that I built. Basically, the ultimate AI agent, and I gave this name. It might not be the ultimate, but I think it's a nice and catchy headline. Basically, I built an AI agent with the AG2 framework, formerly known as Autogen. And the goal of this agent is to be like a personal assistant. And I connected it to many different tools, such as Gmail. So it has the following abilities: sending email, marking email as read, creating drafts, deleting emails, etc. It can do different calendar related stuff, update calendar event, send calendar event. It can analyze spreadsheets, update them, get emails from a specific spreadsheet that contains names and emails. It has different search capabilities because it's connected to Serper, so it can search Google via API. It has a ability to manage my project via Trello. Obviously, it has Google Drive tools, ability to transcribe YouTube tools, and scrape websites. And there are a few more abilities in the pipeline, such as connecting to Google Ads, generated videos using Minimax, which is a model that generates text to video very well, and connected to Google Ads, Facebook Ads. This is an ongoing project. I created a video about this the other day, a few days ago, and now I've been playing around with this AI agent. By the way, it's all operated via Telegram. So I send the agent a message via Telegram. I ask it to do something, and then using these tools or using just the fact that it's connected to LLM, it generates a response. Now, the whole idea of this video is the fact that although I know that automations constantly break, and even when you build a very rule-based automation, like a workflow automation with an RPA tool, you constantly need to adapt and adjust. I must admit, on one hand, I'm not surprised because LLMs are probabilistic and you don't really know what to expect. But on the other hand, a few things broke that I didn't expect to break. This is why I decided to record this video and share some learnings or how I am going to improve my agent in order to mitigate the amount of errors that it throws, in order to reduce the probability of encountering false negatives and false positives. Before I move on, obviously I invite you guys to subscribe to the YouTube channel. And if you haven't subscribed to my newsletter, it's called nofluff.online. Just a few bullet points that I send every week with interesting stuff that I stumble upon in the world of AI agents and automation. Okay, so what's going on here? Okay, so autonomy versus predictability. I created this small graph. On the y-axis, we have predictability, and on the x-axis, we have autonomy. So here below, we're basically asking what's going on, because there's no predictability baked into the system, into the workflow. And when there is high predictability, we know what to expect. On the other hand, on the x-axis, we can provide zero autonomy, or we can let the LLMs or the agents roam freely, and then we have 100% autonomous agents. Now, each quadrant represents something different. So top left, low autonomy and high predictability, is like an RPA tool or a rule-based agent. The agent follows predefined rules, ensuring outcomes are exactly as expected, but little scope for creative adaptive responses. So for this, we don't really need agents. We can just create a workflow automation. And I created these images using Flux just to represent each state. So this is amazing, by the way. I highly recommend checking out Flux Pool ID with ControlNet. So I wrote processing, please wait forever. As you can see, this is the bot. So this is the first state, like RPA tool. The second state, top right, high autonomy, high predictability. This is what ideally we would like. We would like to know what we are getting from the agentic workflow. But on the other hand, we don't want to bake many rules and constraints into the system, because then if if we are running only on tools and we need to think upfront about all the rules, so what's the point of the AI agents? It's not autonomous. It's basically a workflow automation. Let's see the image that it generated to represent it. So this is an AI master chef. In this case, it's a master chef because we know exactly what we will get and it's going to be good. The next quadrant is high autonomy, low predictability. So I believe we are in this state at the moment if we don't use tools in the agentic workflow. It's an environment of free-form exploration. The agent operates independently and creatively, but without sufficient constraints, leading to outcomes that can be unpredictable and sometimes misaligned with goals. So this happens very often with LLMs if we don't bake into the process many rules. Let's see. I'm not sure if we should skip the images or not. Yeah, so this is what we got. A robot with wild eyes, juggling chainsaws, paintbrush. Trust me, I know what I'm doing, but it didn't write, trust me, I know what I'm doing. Probably because we gave it too much freedom and the temperature is not well adjusted. And we have the bottom left, low autonomy, low predictability. This is complete chaos, an environment of freeform, a rarely desired state where the system is both over-constrained and yet somehow still produces inconsistent outcomes, potentially due to external uncertainties or internal conflicts. So this is the worst situation that you can be in. And this is how it looks like, error 404. Moving forward. Okay, so these days when I'm not building agents or working on projects, I often play with one of my two daughters. And we just bought my 3-year-old daughter a building, like a package of magnets, which she can connect and build buildings or whatever she would like. And what's fascinating is the fact that she never overthinks. She just takes the magnets, start throwing them together, and eventually something, very often, although I'm not objective, very often something beautiful comes up. So this constantly reminds me of the fact that we move forward by trial and error. And this is the same when building automations workflow. So basically, we often discover that success doesn't come from perfect planning, because I built the ultimate AI agent and I thought that it was already perfected. But whenever I start running it, I encountered errors that I didn't even think of. Now, as I said, AI agents are powered by LLMs, and they are inherently stochastic and probabilistic. Unlike traditional programming, like a Python script, where the same inputs always produce the same output, these models introduce variability and unpredictability, making trial and error not just helpful, but essential. Now, I wanted to drop like two interesting discoveries that were related to trial and error. So first of all, the discovery of penicillin. Basically, there was this guy, one of the most important people in history, so Alexander Fleming, didn't maliciously plan to find the world's first antibiotics. He recognized the significance of an apparent failure, a contaminated petri dish that most would have discarded, but basically the mistake that he left the petri dish and then he realized the reaction after a few weeks, this made him understand the contamination process, and this led, after many years, to the invention of penicillin. And the second thing that is related to trial and error is the tower building experiment. I don't remember the exact names, but basically they took a group of 3 groups, one of students from Ivy League, another group of CEOs, and the third group was a group of kindergarten kids, and they told each group to build a building, and I don't know what they gave them. I don't know, carton boards or maybe even Lego, I don't remember. But the funny thing is, the legend says, or the experiment says, that the group of kids always outperformed the CEOs of the companies and the Ivy League students. And why was that? Because the kids immediately started building, testing, failing, and rebuilding, while the executives and the Ivy League students spent valuable time planning the perfect approach. And the thing is, in life in general, we have so much randomness. We have randomness baked into anything, so it's kind of stupid to plan. And especially when messing around with LLMs that are inherently stochastic, it's mostly, it's mostly about trial and error. Now, how do we apply this mindset to AI workflow automation? When connecting AI agents to create automation workflows, first of all, we must embrace iteration. So rather than attempting to build the perfect workflow from the start, we begin with a simplified version and refine it through testing. And this is also relevant to any workflow automation. Next, we learn from failures. So each unsuccessful attempt provides valuable data about how your LLMs interact within your system. And I will show you the takeaway in a moment, but this is why logging is so important, because you must know exactly what happened in the conversation between the agents in order to improve this, perhaps adjust the system message, perhaps instead of adjusting the system message, you take a part of the process and you create a tool that is designated to solving the specific subtask instead of writing the subtask in natural language. Obviously, we also need to monitor unexpected behaviors, again, related to logging, and we must design workflows to handle variability and creating systems that can adapt rather than break when facing unexpected inputs or outputs. So obviously, try catch error blocks, and a few more things that I will mention in a moment. Now, I guess the most successful AI automation architects, although I don't know many of them, they understand that perfection isn't the goal, but effective adaptation is. By embracing the trial and error process, we can build resilient, creative, and effective workflows. Now, this relates to the last point of build resilience is related to reflection abilities. And this is something that is very important in the workflow, and many people still overlook this, in my opinion. For every workflow, we have basically a few alternatives in order to criticize or monitor the workflow. And I'm setting aside the try catch error blocks and the logging. Basically, we have one route, which is the human in the loop route, in which the human takes an active part in the conversation with the agents and can guide them and provide criticism. And the other vector is using baked-in QA or baked-in reflection abilities. So for this, we have the agent critique, which is a library that was built by the AG2 team that basically has an ability to build an agent that can read the task that was given to the execution agent. And based on this, it defines parameters to criticize the task, and it can provide scores based on these parameters. So let's say, as an example, I have a task that is related to writing a headline for a Facebook ad. So I send this task to the agent, the copywriting agent, and I also send it to the critique agent. The critique agent sees the task and it analyzes which parameters are important for a good headline. So parameter number one can be curiosity arousal. Parameter number two can be showing the unique selling proposition. Parameter number 4 can be well written and witty, for example. So the agent critique is going to generate parameters, and the copywriting agent is going to create the output, so generate the headline, and the headline is moved forward to the critique. Now the critique can analyze the headline based on these parameters, and we can define upfront if the average, let's say the score go between 0 to 10. If the average score isn't 8, do another iteration. So this is the flow of the agent critique. There are more layers to this because you can also add a verification level, but I will cover this in a moment. We also have a self-reflection ability, which basically the agent can create the copy and then it can self-reflect, and it can also do this in a nested conversation. I don't love this idea because I think it has holes in it, because very often we see that the same LLM doesn't provide great criticism to itself. So LLMs are biased in a way. So when they are criticizing themselves, very often they like what they did, kind of like human beings. Another way to reflect is rule-based verification. So if we have something that isn't a headline, but something more, true or false, with a true or false nature. So let's say we give an agent the task of verifying an email or finding an email of a prospect and sending it back to us. Instead of moving forward in the workflow of the automation, we can add like a condition that says, does an email exist? If it exists, moving forward, otherwise the agent should start another iteration. So this is just rule-based, pretty straightforward. And obviously we can do a chaining of reflection ability. So we can start with self-reflection. Only if the self-reflection yields good results, we move to an agent critique that analyzes based on the scores. Then based on the score, if the score is high enough, we can use a rule-based agent or a condition. And at the last stop, we can decide that we add a QA by a virtual assistant or the guy who built the actual code. So a layer of human in the loop. Now, I wanted to build in this specific task of the AI agents, what I wanted to do, I wanted the agents to look in my newsletter, which I invite you to join. And every time someone subscribes to the newsletter, what the agent does, it fetches the email and it finds whether or not the email is an email of a company or is it a personal email like a Gmail. And it analyzes the prospect. So let's say I got an email from Yaron at EcomXF.com, which is another domain that I have. The agent is supposed to find Yaron at EcomXF.com, go to his website, scrape the website, find information about the company, go to LinkedIn, find information in LinkedIn, and send over a summary whether or not I should personally connect to the prospect. Now, in theory, this sounds amazing. But in practice, I started encountering many errors. So as you can see here, I don't want to expose private data of people who joined, but I started encountering things that I didn't expect. And this is why I'm sharing this learning. So one of the lessons is, first of all, never scrape full pages, because I scraped a full page. And then there is a ton of HTML, and it just creates a ton of tokens, and it creates a lot of noise, and it usually breaks the whole automation. So don't scrape full pages. The next lesson learned is, in this workflow, I have the caller agent, which calls a specific tool, and I have an execution agent which executes the tool. So you must make sure that the caller has data about the tool. So this sounds pretty straightforward, but in my original system message for the caller, I didn't write in a very clear fashion what are the tools and what does each tool do. So this is something that I'm going to add now for every agent that does cool tool calling. I think I need to add a better description of the tools. Another thing is, never forget which tools do you have. So I had this notion that I have all the Gmail tools that I need, but apparently I didn't. So I asked it to find a specific email based on a specific subject line. But funny enough, I had like the right email function, delete email, mark as unread, create draft, etc. But I didn't have the find email tool, which I thought that I did, but I didn't. So many iterations, all the time, the workflow broke, and I didn't understand why. And then I kind of looked deeper, tried to analyze, and I saw, okay, I don't even have this tool, so I had to create this tool. So this is important. Never forget which tools you have. And this transitions me to logging. So logging is so crucial, because basically the agents are operating under the hood. They are going back and forth with the LLM. And if you don't have organized logging of what they do, how can you analyze the workflow? So this is why I can't stress this enough. Logging is very crucial. There is also a layer of observability that Autogen Bench introduced many months ago, but I want to do a dedicated video about observability and telemetry and logging, so I will leave this aside. Demo, I already showed you the demo, like the agent run summary, which is a form of logging, but it's not good enough. Now, before we conclude, I want again to invite you to subscribe and leave a comment below with your feedback or ideas regarding how we can improve the agentic workflows. Obviously, again, join the newsletter, and if you need any help or strategy in implementing automation in your business, feel free to reach out to the email here. I also share the LinkedIn, my LinkedIn profile in the description. Okay, so a quick summary, guys, of the video. AI agents workflow. First of all, it's about expectations. We must align expectations and realize that the bottleneck, in my mind, the biggest bottleneck is the ability of the LLMs at the moment. So since LLMs are strong and powerful, but they are not there yet in terms of providing the agents complete autonomy, we must understand that if we provide autonomy, very often we reduce the amount of predictability that we will get into like the workflow. This is why it's very important, first of all, to log everything, and second of all, to add layers of reflection or verification. And this is under the assumption that you eventually want to use the AI agents in production level and make them useful for real life. And in real life, more often than not, we have reputational risk and we have many other risks that we can't really allow the AI agents to roam freely and produce bad output. So yeah, I guess that's pretty much it. Logging, adding reflection steps, and understanding that at the moment, you're either going to add more predictability by trade-offing autonomy, or adding more autonomy, and then you just need to improve the whole workflow in terms of the reflection and the limitations and guardrails. That's it, guys. Until next time, keep on automating.